OBS හරිද to preserve the video quality. Right, students, you can hear me and you can see me well, right? Confirm that, and you can see the board clearly. Okay, right, then let's start. Okay, are there any new students today? Are there any new? If you are new, if possible, tell me your grade in the chat. Grade if you are new, grade 10 or 11. Okay, right, hurry. Then you can take the you can download the note, the grade 10 short note. It's in the chat. Okay, let's start the session today. So lesson number 2, computer systems. Lamai harida computer systems. Okay, this is the case. Computers can be categorized based on size and technology. What? Listen carefully. Computers can be categorized based on size and technology. That means, sir, are the computers are in 2 categories? No. This is the way. Now assume yourself, based on your age, we can categorize you as a minor or a adult, kid or a adult, can based on your age. Based on your gender, we can categorize you as a boy or a girl, based on your gender. Can you understand the difference? Based on your age, we can categorize you as into 2 different categories. Based on your gender, we can categorize you as 2 different categories. Likewise, computers we can categorize based on size, based on technology. Based on size, we can categorize them into under what? Supercomputers. We have supercomputers, we have mainframe computers, we have mini servers, mini computers, and day-to-day use microcomputers. Those are the 4 categories. Is it clear? Those are the 4 categories. Based on the size, we have these 4 categories. Based on the technology, we have mainly 2 categories. Yes, we have 3, but mainly we have digital. For the Kahoot, please remember the words. We are playing some games today. And analog, right? Based on the technology, we can categorize them as digital and analog. Let's keep these 4 aside for a bit. Let's come to this part. Technology. Based on technology, my digital and analog means inside your computer, there are wires, there are circuit paths, there are a lot of things. So the easiest way to say this to you, as you get the full idea, is like this. Wait. So the signals inside your computer travel as digital signals. Now, if the signals inside your computer travel as digital signals, those are going like this. Like this. See, those are going like this, like that. That means this can be 0, this can be 1, this can be 0, this can be 1, this can be 0, this can be 1, this can be 1, this can be 0, this can be 0, this can be 1, like that. Up and down signals are the digital signals. We have a similar name. Does anyone know? For the digital signals, we have another similar name. What is that name? If knows, tell me in the chat. If you know the similar name, tell me in the chat. Don't know? No one knows the. Now remember, the similar name is, I'm going to erase this part. The similar name is Lamai, discrete signals. What? Discrete signals. Lamai discrete කියන්නේ low and high signals. Then analog means Lamai like this waveform. See, the signal travel as waves. And another similar word for the analog signal. Then what is the similar word for the analog signals? Then we can say waveform signals. You can write these in your notebook. Take a notebook and write. It will be very helpful. Waveform signals. What is the difference? Let's draw the example. These are digital signals. These are ones, these are zeros. These are analog signals. These are analog signals. That is the main difference. Is it clear, Lamai? Is it clear? Tell me in the chat. Is that part clear? The computers, based on size, we can categorize like how you, the person, we can categorize as a kid or an adult based on your age. Based on your gender, we can categorize same you as a girl or a boy. Like that, computer, based on size, we can categorize into 4: super, mainframe, mini, micro. Mini and micro. Microcomputers. Okay. Based on technology, we can categorize into 2: digital and analog. Digital means Lamai discrete signals. That means high and low signals. Analog means Lamai waveform signals. Signals are traveling inside your computer as waves. That is the main difference. Is this part clear? If you have any doubts based on the things I just now taught, put me a message in the chat quickly. Waiting for the chat. No doubts again. Right. No doubts? Clear? Right. Clear. Okay. Najma, after a long time. Okay. Right. Clear. Okay. Fine. Right. Then the next part. I told you another one technology is there. We have, you can see it in the note. We have hybrid technology. Both the technologies together. We have hybrid technologies. Hybrid technologies. How we can use the hybrid technologies? Both the signals are converting to back and forth to do the communications. That means inside the system, they use digital signals as well as analog signals. Whenever needed, the signal type is changing. That is not required in your syllabus actually. I just taught you. You have another one combining both as hybrid system. Hybrid means digital plus analog. Nothing big. Very simple. It's very simple. Right. Let's jump back to this part. The size, based on size. Now, where can we see supercomputers? Have you ever seen a supercomputer before? Shall I show you one? Quickly. A supercomputer. Okay. No, it's recording. Yes, it's recording. Hurry. Here I can show you a supercomputer. This is a supercomputer. Wait until it loads. Cray 1 supercomputer. Okay, here see. This is the shape. These computers can be seen. These computers can be seen in where? Any examples you know? What kind of companies use these kinds of computers? See? It's very big. Bigger than yourself. Any examples you know? Where can we see these kinds of computers? In we have the examples. NASA. Examples are given mainly in NASA and mainly in SpaceX and very large scale organizations, very big organizations that needs intensive amounts of, intensive means what? Deep. Intensive means more deeply. Right? So intensive amounts of calculations and predictions and analysis. So those words are really big for you. Don't think now. So supercomputers are mainly for analyzing things and do hard calculations like that, big things. So the companies that they use these supercomputers are NASA, SpaceX, like that level of companies, like that level of companies. Any doubts? No, neither. Yeah. Amazon. Amazon. Does Amazon use supercomputers? Let's check. Let's ask from AI. Does Amazon have supercomputers? Yes, Amazon is actually building and operating some of world most powerful supercomputers. Amazon is telling that here we have the source. They are building one. Eh? They don't have one, I guess. They are building one. So yeah, good awareness. What's your name, dear? Really good, huh? Good awareness around the world. Harikshan. Okay. Right. Then, what else? What else? What else? Then mainframe computers, Lamai. Mainframe computers used in what? Used in where? Moderate size computers. These computers are specially multi-user computers. What is mean by multi-user computer? Now take your computer, take your CPU. Can you plug your monitor, your mouse, your keyboard to your computer plus your friend's monitor, friend's mouse, friend's keyboard to your computer? Can you both use the same CPU? CPU means the system unit. Same time, can you do that in your normal computer? Can't, ne? You can't do that, ne? There's already no any port for two monitors. Ne? We have only one monitor port, VGA port or HDMI port. We have only one. Ne? So in mainframe computers, guys, here we can plug actually more computers, more multiple users to same one system unit and use. Let's see one mainframe computer as well for your idea. Let's quickly see a mainframe computer. Mainframe computer. Ultra powerful, secure, reliable systems designed by organizations for massive scale real-time data processing. Still big, like this. This is a mainframe computer. You can see still big, but not bigger than supercomputers. Supercomputers are still better. So mini computers are now servers and smaller, less powerful, but still powerful. Let's see mini computers. Like these are not mini computers. Actually, in your syllabus, they are saying as mini computers, but actually server computers. Let's see server computers. Server computers. Like these. You see, like tray-like structure. This is the actual image. You have tray-like structure. These everything is a CPU, Lama. You can see here. Can you see? I'm pointing to the image, Hari. Think that I'm pointing to the image. You can see 1, 2, 3, 4 like that trace here. All those are what? separate CPU, separate servers. Whenever they need, they can pull out one computer and add back another. If one broken, they pull out one server and add back the other server. These will be very useful for the organization like banks. Early, even YouTube and Google use this method. Now they have bigger data centers with mainframe and supercomputers as well. Banks nowadays, the banks and some organizations, some big country level organizations, not global level organizations are using now bigger ones. Country level organizations are using mini computers. What is mean by a microcomputer here? What is mean by a microcomputer? You have logged into this meeting using a microcomputer. That means your mobile phone. Okay, hands up the people who joined via a mobile phone. Hands up the students who joined via a mobile phone. From a laptop or a computer, all are microcomputers. All are microcomputers. Clear? Okay. Here's the compact, designed for personal use, laptops and handheld smartphones. Lamai, you have to study this table. This table is very important. It will be asking in the exams for sure. At least one question from this table it's asking in every O-level exam. You have to study this table. That's why I have compressed your textbook, that these pages, into this one table, so then easily you can study this content. This content can be easily studied. If my English is hard for you, please let me know. But I can't talk in Tamil anyway. I can understand Tamil. If you want to chat with me in Tamil, it's okay. I can read and understand. But பேசுறது கொஞ்சம் கஷ்டம். சரியா? Okay. Right. Then we can move to, is it okay? Shall I give some time to study? Because in the Kahoots I am asking these questions. I am giving you 5 minutes. 9:25 I am moving to the next part. Right at 9:25 I am moving to the next part. Before that, study this table. In the Kahoot game, you have to play with this knowledge. So we are conducting a game. If you don't know about Kahoots, please drop me a message in the chat. I will teach you what the Kahoot is, because I think some new students are here today. If you don't know anything about Kahoot, Anna, quickly tell me. Kahoot is a small game. Hurry. Okay. Kahoot is a small game. Game in the sense, I am giving you MCQ questions. You all are connecting to that game through your mobile phone. So you are playing with each and every person. Hurry. Okay. Sir, can you explain the technology part again? Okay, sure. So here, technology, based on the technology, we have two technologies mainly. Digital, analog. Digital means the signals. Actually, these are signals, both the analog signals and digital signals, right? Here, digital signals means inside the computer, the signals are traveling like discrete values. This form, we are calling this form as a discrete value. Discrete value means high and low signals, 0, 1, 0, 1. So this is very easy for the computer, and this is very faster. Digital signals, right? Analog signals the other way. It is waveform, little bit old. This is little bit old. Analog, but still using for some use cases. Still we need analog. So in the analog we have waveform signals. Waveforms means these are waves. So signals are traveling like waves here. Waveform signals, right? These are similar words. You have to remember these words. Digital means discrete values. Analog means waveform signals. You have to remember those wordings. Is it clear? And we have another one, connecting both. That means inside the same system, they are shifting from digital to analog whenever needed. They are shifting. So Those systems we are calling as hybrid technology. Hybrid technology. Hope it is clear. Drop me a message if it's clear. Tell me. If not clear, please tell me. I'll tell it shortly again. Clear. Right. Okay. Study the table for the game. You will need it. It's clear. Okay. Right. For the game, it will be useful. Please study the table, entire table, but not for the game. Actually, think when you are studying for the when you are studying anything, think that you are studying for the exams, really, for the O levels. You should keep it long term. Once I told you the technique. If you study for the short term, it will be in your short term memory. You have to continue studying the same thing again and again to shift your content into long term memory. If not, it won't go. It will stay in the short term. You have to continue the studying the same thing again and again. That is the only key for a good pass. Okay. Right. Shall I move to the next part? I'm moving. Okay. Computer architecture. Von Neumann architecture. Okay. Now, Lamai, this is a hard part for some students. Did you write this? If you didn't write this chart, take a screenshot, write it later. Take a screenshot and write it later. Let's move to the computer architecture. This von Neumann architecture. Von Neumann architecture means very simply, if I am going to tell it simply, storing and taking whenever needed. That is the von Neumann architecture. So we have input devices, output devices, processing unit, which is our processor, and storage. We have input, output, process, and storage. So we can collect data from our input devices and we can store it in our hard disk. Whenever needed, we can take it out and process it and give the outputs. This is called von Neumann architecture. Okay, didn't went to your head? You still didn't get it. What is von Neumann architecture? No, sir, I don't have any idea. Okay, listen. I will teach you. First of all, before going to the von Neumann architecture, I'm telling you now, take a book, please. Take a book, take a writing book. If not, I can't place these concepts in your mind harder. Please take a writing book. I'm going to teach you what's inside the computer really. Let's take a 3D image of a computer inside. Please drop me a message, students. Have anyone disassembled a computer before? Have you seen inside a computer before? Inside a CPU, I mean system unit. Really good. No, there are you? Computer haven't disassembled? No. Oh god. Okay, this is my processor. Here, see processor. I will show you. But for now, let's see this part. This one. Okay, here we have a computer. I can't show you a real computer. So here I can show you only inside like this from a 3D model. I think this is enough for now. Wait. Right, okay. Right, you can see this is the inside of a computer. Hope you can see it clearly. Now here can you see a small green color box connected with red color wires? What is that? If you know, tell me in the chat. What is this? Here you can see. Here. Yeah. You can see a box. Green color box. What is that? Does anyone knows? The red color wires are connected. No idea. Come on. Okay. This is your system unit ne. Take out your writing book and neatly draw this. Now I can't draw sharp lines in my board. Okay, Lamai, don't laugh at me. I have this one. You know this one, eh? I'm going to use this as my ruler because it will be very ugly if I draw from my hand. Eh? So please take your writing book and draw this. Huh? I don't know the name for this. What is the English name for this tool? Pitakasaneka kila kina Sinhala. In Sinhala, we are telling it like that. Okay. Right. Draw a box in your CR book. Draw a big box. We are drawing the inside of a system unit. You can see that here as well. Right, okay. Now, here we can see a big box. I am going to draw that here. This is my hard disk drive, Lamai. This is my hard disk drive. HDD in the sense, HDD means hard disk drive. Hard disk drive. What is the purpose of hard disk drive? For what we are using the hard disk drive really? What is the main purpose? Yes, storing what? We are using the hard disk for. Storing data. This is our storage. This is our main storage. We are storing our operating system, our files, your images, your selfies, everything. Your windows, what else? Everything, really everything. Everything is stored in where? In the hard disk. Okay, inside here in this image, you can see some wires here, red color wires. Those are called my SATA cables. SATA cables means actually they are responsible for the powering and carrying out signals inside the computer. Now inside the computer, all the components are actually it's like components, separate components inside the CPU. Hari. So the communication, all the components are connected to motherboard through these SATA cables. Now what is motherboard? Anna. We have motherboard. This one. I drew this one is motherboard. Hari. This is what motherboard is. All the components are connected to the motherboard. So the hard disk also through the SATA cable, it's connecting to where? To the green color big circuit which is motherboard. Hari. Okay. We have the data here. When you turn on, there are some steps happening, post and BIOS activation, and I will teach those part in the OS lesson. Those things are in the OS lesson. For your knowledge, for this lesson, when you are powering on the CPU, this content inside the hard disk will load into where am I? It will load to RAM. Now give me the full form of RAM. Quickly inside the chat. Tell me the full form of RAM. Make it quick. Store data. Okay. RAM means, Zahara is telling, random access memory. Correct. Random access memory. Lamai, now tell me this correctly soon. Is RAM volatile or non-volatile? Tell me that. Volatile. Volatile in the sense? Very good, Rasak. Volatile in the sense meaning. Volatile means what? Okay, this is the easy way to memorize this. Volatile equals like evaporating. Evaporating means data is vanishing when the power is unplugged. non-volatile. What is mean by non-volatile? Non-volatile means even the power is not there, data is secured, it's not going off, it's not fades away. So our hard disk is lamai, hard disk is non-volatile. Non-volatile, you can write this down, non-volatile. But our RAM is lamai volatile. When you power on from the hard disk, data will load to RAM. When you remove the power, when you switch off the computer, that data will be vanished. Those data will be vanished. That is why Lamai, we have our capacity of RAM is nearly 4 GB to 16 GB in normal computers, the computers that you are using. Sometimes if you are a very rich person, you can have, Lisa might have, Lisa is very rich. Now, her computer's RAM is nearly can be 64 GB. I don't know. Is that true? So here, usually our RAM cards capacity is like this. But our HDD, our hard disk capacity is more than 256 GB. It's more than 250. Why? It is storing for the, it's storing permanent. So we have to store a lot of data. It is permanent. It's storing until we delete it. RAM, it's not storing like that. It's just a memory. It's just a memory in the sense it's taking whenever the data is needed only. Once the power is unplugged, the data is vanished. That is the reason we need more capacity, here less capacity. Is that clear? Neither. This is what is your RAM. In your, okay. Message okay, volatile, okay, correct. Right, then this is RAM. When the data is, let's say OS, operating system, data in the sense operating system at first, when you power on the CPU, operating system really loads at first, then only when someone clicks something, that data will load. So at first operating system, or else when you do something, the relevant data will load into RAM. Then you have the CPU here. I will draw it a little bit bigger. This is our CPU. Why I drew it bigger, I will tell you the reason. Wait. So once the RAM has the data, it will go for the cache memory here, which is just outside the CPU. This cache memory we call as L2 cache memory, L2 cache, which is just outside the CPU. L2 cache, Lamai. Have you ever visited Dansal during Vesak time? Have you visited Dansal? Dansal? Do you know that? Ever visited? No? No responses. Dansal appat kala ne. Okay, yes, okay. Okay, no. Yes, okay. In your Dansal, we have a queue. Queue in this is polling. We have a polling. Here, there is a person holding the entire queue without letting you go inside the Dansal until the space inside the Dansal is getting available. If the space is not there, one person right at the door, he's stopping the load until inside gets cleared. Is it? Did you understand? Same operation happening by what? L2 cache memory. It's holding the data until from the inside someone tells him, okay, now send. He's holding the data. So inside the CPU, we have another small memory called, this one is called L1 cache. This is inside the CPU. L1 cache, level 1 cache. Now he is holding what is sending by this L2 cache. So when the HDD sends the data to RAM, RAM sends to the L2 cache, L2 sends to where? L1 cache. L2 sends to L1 cache. Here, now L1 cache can hold, then it will go to where? Registers, the smallest memory, registers. These are called registers. Smallest and the fastest. I will tell you the reason. Wait. Then after that, the data will come to this one. This is called, why sir did you draw it like a trouser? Just the scientific shape. ALU, arithmetic logic unit, which is the brain of the computer, which is the brain of the CPU. Yes, this is the CPU, the small chip. Inside that chip, we have all these. We have more, actually, we have more. We have data bus, control bus, and much more things. MBR and all. So for your understanding, this is more than enough. What? From the HDD, OS loads to the RAM. From the RAM, it loads to the cache memory. Then from the L1 cache, it sends to the L2 cache, it sends the data to the L1 cache. It sends to the registers. Now registers are sending these data for the ALU to operate. ALU does the logical functions and the mathematics. If it is a calculation, he does the calculation. Or else, if it is a what? If it is a logical function, he does the logic and gives the output same way, right? There's another technique to remember this. Up to here, tell me, Lamai, is this thing clear first? Or if you have any doubts, please tell me. Yes, clear. Right. Tell me, is this part clear up to now? Up to now clear. The data, this is the order it loads. This is the order it loads to the system. It's like this. Okay, clear. Okay, it's like this. Lamai, listen. Now our Najma is a Mason bus. What? Clear. Okay. Our Najma is a Mason bus. She is making the Lisa's house. Now this is Najma. Let's say I will erase this area for the drawing. Listen, this is Najma. Mason bus. Her job is to make a wall, make the house. Now she is making a wall, one wall. This is her wall. The cross view, the side view actually. This is the wall. She is making a wall. I am not well at drawing. She is making this wall. To make this wall, she need what? She need bricks. These bricks, assume, the Lisa is giving the entire brick load to Najma when at the time of she making the wall. She is making the wall. At that time, this Lisa is giving entire the brick load to her. Like here. Does she putting entire brick load here like this? No. Brick load, the lorry will land the bricks into a separate place, separate load here. Separate load. The bricks will be a separate load like this. So, Najma, what you are doing is, you are taking some bricks to a wheelbarrow at first. You are taking some bricks to a wheelbarrow at first. Then you are taking that bricks to near you. Then you will put some bricks to a tachi. Metal plate. The metal plate. You will put some bricks to the metal plates. Listen this story carefully. You are putting some bricks to the metal plate. Now what you are doing? From the metal plate, you are bringing it near to you and you are placing some couple of bricks near you. From your hand, this is your hand. Let me draw it nicely. This is your hand. You have the brick that you are going to put it into your wall. This is the working brick. Now what is the story here? What is the story? Now see, according to this story, which capacity, now these are capacities, brick load space, it's a capacity, wheelbarrow is a capacity, this plate, metal plate is a capacity, Najma's hand is a capacity. Which capacity is the smallest? And the message me, which capacity is the smallest? Smallest capacity. Which can hold the least amounts of bricks? Which one can hold the least amount of bricks? And tell me. Okay, hand. Very good. Najma's hand. Yes. And which one has the highest capacity? The brick load space. The brick load space. Brick load space. That has the highest capacity. Same way here, same way inside the computer, hard disk has the highest capacity. Which one is having the lowest capacity? Register. Same story here. Same story here. Now, when you come and think about the access speed, that is the key point. Access speed. What is the word, Lamai? What is the word? Remember carefully. Access speed. This is the main word. This is the reason why the computer architecture is like this. Access speed. Okay, think it as like this. If Najma going for the brick load again and again for each and every brick, bring it back and applying in this wall. What about Najma's access speed? This is high or low? If Najma need to go for the each and every big brick, she needs to go for the brick load and take it back and come. Is her access speed is low or high? Low or high? For each and every one brick, now it's like now Najma is putting one brick here, going for the next brick, taking from the brick load, coming and putting in the next brick, and going for the next brick load, like that. This way, Lamai, Najma, you won't do the work, ne? You will slap hard for the Lisa's face and you will go home, ne? You won't do this job, ne? Why? This is very hard. You will eventually ask a wheelbarrow, and that's why we have put a RAM here. That's why we have put a RAM here. Why? From the wheelbarrow, you can take the relevant amount at the time. At one time, you can take some amount for the wheelbarrow and take it near you. That is the exact reason we are using a RAM. We can take the relevant data only when it's needed and load it when it's operating. When she is operating, she is working. Same way the ALU is working. Got it? So here, from the start, she's taking some bricks near her and taking one by one. That is the exact reason this is happening. So which one has the highest access speed? Which one has the highest access speed? Access speed can take quickly. Access speed. So if she can't take quickly, the access speed is low. If she can take the thing quickly, the access speed is high. Okay, now here, which one has the highest access speed? Hand. Which one has the lowest access speed? The brick load. So same way in the computer, which one has the highest access speed? Which one has the highest access speed? Now tell me. ALU is Najma. Now the ALU is the Najma. ALU is the Najma. So for the Najma, which one has the highest access speed? Which one has the highest access speed? Tell me. ALU is not a memory. ALU is not a memory, Lamai. These are the memories. Listen carefully. Hard disk is like the main storage. RAM is a memory. Memory means short-term memory. It's storing the data only for a short period until it's power off. RAM is a memory. L2 cache is a memory. Holding the data until it's power off. L1 cache is a memory inside the CPU, which is inside the CPU. This is the CPU. L1 cache we have inside it a small memory. Hold in this one like this L1 cache. This is like L1. This is like L2. This is like the RAM. This is like the RAM. This is like the register. This is like the register. ALU is the operator, Najma. It's not a memory. It is the person who is working. Najma is the person who is working. She is not a memory that holds and stays the brick. Yeah, brick ke karagena mehme inna alla she not staying the brick and wait and look at it. She is putting it and making the wall. That is the output. Wall is your output. See, wall is your output. So here you can see what her hand is a storage. Why? One brick can stays there. One brick can stays there. Her hand is a storage like registers. And this one, the small brick load is L1 cache. Tachi is the L2. Those are Lamai. volatile memories. Memories in the sense, at the end of the day, all these bricks will be cleared and put back into the where? The main brick load. That means hard disk. We are not keeping the bricks in these stays, in these capacities for long. To do the work only, we are taking the bricks to the wheelbarrow, to the Tarchi and here and to the Najma's hand. After the work is done or work is partially done, or at the end of the day, she is clearing this one, she is clearing the metal plate, she is clearing the wheelbarrow, and all the rest of the bricks will be in the load space. Likewise, here also, these all the memory units are cleared. All these memory units are cleared at the power off. So the person who is doing the calculation is ALU. It's not a memory. ALU is not a memory. Now tell me which memory has the highest access speed. Quickly tell me. Okay. Register. Very good. Register has the highest access speed. Others, correct me? Others tell me, someone tell me, be quick. Which one has the lowest access speed? According to this diagram. Which one has the lowest access speed? Hard disk, HDD, correct. And now you are having the idea. Now, can you have the idea that if the RAM is big, if you have a bigger RAM, like you have a bigger wheelbarrow, that means at one time you can bring back lot of bricks. That causes what? The times that you need to go back to the hard drive is becoming low. How many times that you need to go back and bring the data is becoming low when your wheelbarrow is bigger. Same way, if the RAM is bigger, the time you need to take the things from the hard drive is becoming lower. How many times? The number of times become lower. That is the main use of RAM. So if you apply a big RAM to your system, that is why your speed is increasing. He is not going for the hard disk every time. Lot of data can be stored in the RAM and take whenever the needed. Hurry. So, Lamai, according to this, what is the smallest capacity again? The highest access speed is register. Which one has the lowest capacity? Smallest one. Najma's hand. In the computer architecture, what? Which one has the smallest capacity? Again registers. Understood there? Is it clear? Right. Is this part clear now? Let me know. If it is 100% clear, let me know. This entire thing that I have drawn. Najma Tanang clear key, it's okay, yes. Arikshan, okay. Others. Najma clear. Lisa, what happened? Zahra, okay. Lisa, confusing. Fatima, yes. Any others? Okay, is this the first time you learned this? Tell me that. This is grade 10 second lesson. Nah? Is this the first time you learned this? Or you have learned it before? I just need to know that as well. Yes, okay. First time. Okay. So, hope you got the idea and hope you know the worth of this session now. Hope you got the idea plus the words. Right, okay, then now here let's jump back to our, yes, this much clear now, only I have learned this time. Okay, thank you, Hariksan. Yeah. Okay, here now let's jump back to our 3D viewer bit, Lamai. Here, now this is just out of the syllabus. I am just teaching you this part for your understanding. We can see some cooling fans inside here. Under this here, you can see, I can show you from the mouse. You can see my hand, a white color hand. Here you can see this big cooling fan. Under that, we have what? And now tell me, under that biggest cooling fan, we have what? Does anyone knows? We have the big brain, the CPU. The CPU is under that cooling fan. Why? This is heating. It does the all the operations inside this chip. Inside this chip. So when it's heating, what happens? This cooling fan takes all the heat. How? Cooling fan is right on top of the CPU, and the heat is, you know, the metals are conductors. It can take the heat out. So to continuously keep the metal conducting level, they have applied some thermal paste. This is not your syllabus content. Through that thermal paste, the two metals are connected, and this metal surface is heating, and it's going to be cooled by the cooling fan. And that hot wind is blowed up. The hot wind is blowed up, and what happens? We have another two cooling fans right at the wall. Here, see, right at the wall. It grabs that hot wind and taking it out, pulling it out. That is the operation that's happening inside the CPU. So that is no need to have the complete idea, but you have the rough idea. That's enough. That's more than enough. Okay. Other than that, what are the things you need to know here? Actually, that's it. Okay, here you can see at the bottom, what is this? My NVIDIA. What is this? If you know, tell me. What is NVIDIA? Does anyone knows? Does anyone knows it? Lamai, what pin? Are you really ICT students? I'm disappointed about yours. No? NVIDIA? Who is the world richest person right now? The world richest, most richest person. His company is NVIDIA. You can search it and tell me. This is general knowledge. NVIDIA means a graphic card. What is the use of graphic card? The primary use is the graphics, controlling the pictures. Now this 3D image is rendered. Why? We have the graphic card in my laptop. That is why this is smoothly rendering. Rendering means operating. Okay, now the graphic. If you are playing a game, hands up, who has played COD, Call of Duty, IGI, NFS, or any other game, any other popular game. To play these kinds of games, you should have a powerful graphic card, the latest ones. Okay, Ash. Ash, what's your real name? Ash Q Amanika. You know? Right. What's the game you have played? What's the game you have played? Roughly. You Ashwin? Another Ashwin. Call of Duty. And I got another message. Razak. Free Fire. Free Fire. Yes. Okay. Ginseng Huang. The owner, the world richest person, Ginseng Huang. He owns the NVIDIA company. The reason he is becoming the richest, and he is continuously going to be rich and more and more. Why? The evolution of AI. To run this AI, the servers need powerful graphic cards. This powerful graphic, the servers need it. So NVIDIA is the main company in the world that manufactures graphic card. Actually, not the main, that is the only company, I think. NVIDIA is the only company that manufactures graphic card. If there's any other company, let me know. So, okay. Let's jump to the next part. Let's see how many minutes do we have. We have half an hour only. Okay, let's come to the next part. So here now we hope you ACC, PC, CIR, those things are registers. You don't need to have know the meanings of these ones. Maybe it's not important. Just those are registers, some different kinds of registers. Right. Okay, then where is me? Okay, right. Hurry. Here you can see the hierarchy. Here you can see Lamai registers, cache. Now you know there are two levels. RAM, you know. All the other red color ones are what? Secondary storage. That means all the other things are from this level. You can see it in the red color. Optical disk, hard disk, magnetic tape, those are storages. Those are not memories, Lamai. From the RAM only we are starting the memory. And we have another small one as ROM, which includes the BIOS. ROM, usually manufacturing company, that is not important for the computer operations. It is important for the primary functions, from primary base functions like turning on the computer, like that. ROM, not random access memory, read only memory. So the data inside it is given by the manufacturing company. You cannot edit it, or it's not changeable, it's not changing by the computer. Right? That's permanent data. Right? And also you have some small battery inside the computer, which is called CMOS battery. CMOS battery. The reason we have this battery is, Namai, when you turn off the computer and turn on your computer next day, still your date and time is correct. Still your date and time of the computer is correct. The reason is your computer is ticking your time even when it is power off. From what power, sir? This battery. Your computer is taking the power from this CMOS battery and ticking your clock, ticking the computer's clock. So whenever you turn on your computer, even in the next day, the correct date and time is there. Understood there? Those are the simple things. We can jump into input devices and output devices. Just read the input devices, output devices, and the ports. Podda balagan. I will teach in the next week. But for the Kahoot game, we need this. Do you know about Kahoot? Does anyone doesn't know about Kahoot? Are there anyone who doesn't know about Kahoot? Let me know in the chat. Hope everyone knows the Kahoot. For that, you will be needing this. So please study. You have the note. This page. Making question එකකුත් තියෙනවා, right? You have one question from here as well. Right? Study what you learned today before starting the Kahoot game. Within 5 minutes I will start. We have provided the note in the chat. If you doesn't have the note, let me know in the WhatsApp or in the chat. I will re-give the note and we will start the Kahoot. Hurry. Okay. Shall we play? Please confirm. Lamai, these Kahoots I have made to play at the end of the lesson. But I am playing it today. And the same Kahoot game I will be playing in the next day. So you know what are the questions that I am asking. So when I am going to teach the next lesson, you will know what are the points that you should memorize. Right? You will know what are the points that you should memorize. Are you ready? Not yet. Physical classes on Tuesday. Yeah. It's on 6 to 8. Usual time. 7 to 8:30 Ramazan time. I'm getting messages from the WhatsApp as yeah, okay. Ready, sir. Where, sir? Okay. Wait. Okay, shall we start? The others ready? Lisa, Najma. Ready there? Shall we start? Okay. I'm going to start it. Join, na?
Facilitate the
Right. Okay. There's Islamic seminar, ne? We have to finish it early for that. Yeah, let's finish the game quickly and go. Mm, grade 10, lesson 2, part 1. This one. Okay, the things that I have to teach next week also it's there. Some questions from the next week content also there. Okay, game pin is loading. Students, you can come to kahoot.it and type this game pin, or you can click the link that I am going to put in the chat. I will put the link in the chat. You can click that link and come to the game as well. You can type your name and come to the game. So you will be getting MCQ questions. It is like fastest finger first. If you click your answer as soon, you will be the first in the game. Okay, Ashwin has come. Hariksan, Lisa, the others. Zahara has come. Waiting for the others. Hariksan is there. Najma is there. Any more? Lisa is not playing today as well. Lisa, why? Who else? Shall I start or should I wait? 4 are there. Just wait for 1 minute more. Make it quick. Game pin is 565748. 565748. Amma, you have to bring your friends in to play Kahoots and have the real connection problem. Okay. You have to bring your friends. Then only you can play this with thrill. Okay, with 4 I am starting now. It's okay, others are not joining. Scared that your name will pops in the game leaderboard. You gotta be proud, man. So 3, 2, 1, starting. Okay, again 3, 2, 1. Sorry. Which classification of computer described as compact and for the personal use? I'll give you answer quickly. Which one is for the personal use? Microcomputers, no, not mini computers. Mini computers, I said, those are mini servers. Server in the sense, those are used by some companies, not for the personal use actually. They are using servers to distribute data with everyone, not for your personal use. Microcomputers are the personal use things. Let's see who has won. Najma and Harikshan and Isa has joined. Okay, Najma has given the correct answer. Harikshan has given the correct answer. Others not yet, but you have time. You have questions more. You can try. Don't get demotivated. Let's see what's in the next question. What is the function of arithmetic logic unit? I told you. What is the function of arithmetic logic unit? To perform the mathematical and logical functions, correct. One person has given to store data temporarily before processing. No, to store data temporarily before processing is RAM, cache memory, registers, those are the things. Okay, let's see. Najma is still leading. Harrison second, Ashwin third, Aisha has started scoring. Zara, let's try this question. Third question, according to the memory hierarchy pyramid, which type of memory has the highest speed and cost per unit? Which one is more expensive? When it is near to the CPU, it's getting expensive. When it is near to the CPU, the capacity is going to be very expensive. Okay, registers. Registers is the why. Why? Which type of memory has the highest speed? From there you can take Nilamai. Highest speed. Speed in the sense access speed. Speed means access speed. No one gave me the correct answer, I guess. It's not RAM. It's not RAM. Registers has the highest access speed. Speed means access speed in the computers. Nothing else. So no one gets the points. No one gets the points. But hope you got the idea now. Hope you got the idea. An ECG machine in the hospital, what is the technology it's using? We have discussed about 3 technologies: analog, digital, hybrid. Microcomputer is not a technology, don't hit that, not green. Hybrid, very good. Hybrid computers, yes, you have it in the notes. So, and Zahra started scoring, Najma started scoring, and Najma's lead is very high. Harrison, try, you can give it a try yet. Let's see. 5th question. What is the primary function of the optical character unknown? Now this is, I didn't teach this one yet. I will teach this part next week, probably. Right. Convert printed data into digital data. Correct. Let's see who gave the correct answer. Harrison and Zahra. Nice. 6th question. CD or DVD is which type of external? It's magnetic or solid or optical or sequential access means something else. Don't click that. We have 3 main types now: optical, magnetic, solid. Which one is this? Right, optical. Only one gave the correct answer. Let's see who is this bright case. Harrison. Okay, he is now at the first place. Najma, try again. You still have the chance. Sarah also having the chance. Aisha, you still have the chance. You still have the chance. See. In data transmissions modes like walkie-talkie, luck is important. What is this communication type? I will teach in next week, but for now, just try to give me the answer. Which type of communication? Half duplex, correct. All 5 correct. Very good. Zahra has climbed up. 8th question. Which port is specifically designed to connect high definition video and audio? Video and audio, high definition. It's in the word, high definition. I got 2 answers already. Three answers. 4. High definition multimedia interface lama HDMI port. Okay, 3 correct. Some others gave VGA port. VGA port is okay. It's you can connect old monitors lama. HDMI is the new one. High definition multimedia which we can connect projectors, monitors, TVs and everything, which is with high quality, even 4K, 8K. That's HDMI. Ashwin has climbed up again. Nice game between Ashwin and Zara. And Najma still have the chance. We have two more questions. This is the ninth question. The network that connects computers within a single room or building is known as. I will teach this too. It's not from the today's context. I got four answers. Okay. Each and every box got one answer each. Okay. That means I should teach this lesson. So let's see who got the correct. Harikshan got the correct answer. Correct. Okay. Last question. According to the text, which guided transmission medium considered the fastest? What is the fastest? Hope you know this. I got three. Okay. Just three answers there. Fiber optics two gave me the correct answers. Based on that, let's see, Lama, in the podium we have the third place Najma. Najma has the third place. Second place goes to Ashwin. Really? Didn't expect. And first place goes to Harichan. Okay. Fourth and fifth place, who got? I didn't see that. Okay. Who got the fourth and fifth? Chat me. Chat me the people who got them. Okay. Now, right. Who? Erickson is saying Zara and Aisha. Okay. Okay. Then, students, in this class, now this is the second lesson, starting of the second lesson in grade 10. Within 1 year, I am covering the entire syllabus. So until Ramazan ends, this class is free for you. Until the Ramazan end, plus another 2 more weeks, the class is free for you, and then the paid class will start. It will be paid. And eventually, within the end of the year, every person who is joining from this class for this class, I can't assure the A pass because I don't know your capacity. But if you are a student that who's giving time and joining to these kinds of sessions, means that you are a student who has the will to learn. So obviously you will eventually get an A pass if you continuously join this session. And also now you have another session, Islamic seminar in our EduZone. Its link will be on the groups. If you are not in the ICT group specifically, drop me a message. I will add. My phone number is here. This one, you can note it down. You can ask any subject related matters from this phone number, 494-3352. So I'm conducting the class until the end of the year, until your exams, as a normal class online. So physical classes will be on Tuesdays 7 to 8:30. Any other questions? Yeah, okay. No any questions, ne? Okay, Lamai, then I'm going to end the session today. Hope you have a nice day and good night. Okay, do I have any messages? Good night. Okay. Bye, good night. Thank you.